14th of October Leetcode challenge. The problem that we have in today is delete the middle node of a linked list. The question seems like a very straightforward question where you are given a linked list. What do you need to do? You need to identify the middle element and delete it up. You need to return the updated linked list after the deletion, and this is what the question is asking us to do. I'll be explaining you this question as well as the example why the presentation, so let's quickly hop onto it. Also, we have solved similar questions in the past, so the subscribers of Coding Decoded would feel that it's an easy question, it's not a medium level question. For example that was specified, we have a linked list wherein the head is pointing to 1. The elements are 1, 3, 4, 7, 1, 2, 6. The question says delete the middle element of the linked list. So let's divide the problem into two parts. The first one is saying identify the middle element, and the second part is saying delete it up. So let's focus on the first sub problem, which is identifying the middle element. How to go about solving it up? The approach that is to be used over here is the fast pointer slow pointer approach. So what do? You take a fast pointer, you take a slow pointer, and fast pointer moves ahead by 2 positions. The slow pointer moves ahead by a single position, and as soon as the fast pointer reaches the terminal state, your slow one would be pointing onto the middle one. So let's iterate over it. If you're looking for the logic behind it, then I'm attaching its link in the description below, wherein I have explained it in detail. So let's get started. Both of them are pointing to the same position. Your fast will move by 2 positions, your slow will move by a single position. So fast moves on to over here and slow moves on to over here after the first iteration. Now again, let's increment fast to 2 pointers by 2 positions. Now fast points to over here and my slow points to over here. Let's proceed ahead. Now my fast points to 6, and as you can see, this is a terminal state. You don't have any more entry next to fast pointer. Your slow pointer points to 7, which is at the middle of the linked list. So we abort the process there and then itself. So we have successfully reached the middle point, which is 7. You can keep track of another pointer which is known as the previous slow pointer, and while iterating over the slow pointer, you can keep on updating the previous slow pointer during the iteration. So my previous slow pointer would point to over here. Let me just write it as prev slow, and once I have identified this location, previous slow pointer, what I'm gonna do, and now I am solving the second part of the problem. I'll simply update previous slow dot next to previous slow dot next dot next. So what is previous slow dot next? It is this. I'll update this pointer to previous slow dot next, which is 1. In this way, we have successfully solved the two sub problems. First one was identification of the middle element, and the second one was deletion of the middle element. You simply update this node and 7 is gone from the linked list. This is the crux of the problem. To conclude it further, let's quickly walk through the coding section. The time complexity of this approach is order of n. The space complexity of this approach is order of 1. As discussed, I have taken 3 pointers over here. The fast one, the slow one, and the previous slow. Fast and slow are pointing to head. The previous slow points to null. What do? I start an while loop wherein I write fast is not equal to null, and fast.next is also not equal to null. These two are my terminal states for fast pointer for aborting this while loop. I increment the fast pointer by 2 positions. Fast equals to fast.next, and my slow moves by a singular position. Slow equals to slow.next. Along with this, I also keep track of the previous slow pointer. So before updating the slow pointer, I store the slow value in a previous slow pointer. Once I am out of this loop, I have successfully reached up till the middle element. My slow is pointing to the middle one, and my previous slow is just the pointer before the middle element. So what do? I update previous slow dot next to previous slow dot next, and once I have done this, I simply return the head of the linked list. So let's try and submit this up. Accepted. Along with this, if you are interested in solving more questions of the linked list series, then Coding Decoded SD revision sheet is there for you. So if you go and check out this link, you will find the problems related to linked list. I have created a playlist for it, and all those questions that are marked with double asterisk signs are highly important from interview's perspective. It explains a very important concept, and these are like must do. Also, if you are new, then I would say start from easy questions, move on to the medium ones. And if you have a very important interview lined up, then definitely shoot for solving those that are marked with asterisk sign. Also, if you want to build consistency like Coding Decoded, if you aspire for the same thing, then Coding Decoded GitHub repo is for you. If you go and check out October 2020 link, then you will find solutions in C++, Java and Python. The subscribers of Coding Decoded are submitting pull requests onto here. So I'll request you guys come along and let's together build the consistency. Looking forward to seeing more pull requests in future. It can be any language of your choice. Right now we have 3: C++, Java and Python. Previously people used to also code in Kotlin as well. So if we have more developers from different languages, they are more than welcome to contribute over here. It's gonna help a lot of people across the globe who solve daily Leetcode problem. And thank you in advance. Take care. I'll see you tomorrow with another fresh question. And guys, please don't forget to like, share and subscribe to the channel. Your subscription truly means a lot to me. Goodbye.